and welcome to today's session of VMware IT journey to Tanzu Kubernetes Grid. My name is Swapnil Hendre, and I'm Director of Solutions Engineering and Design team in VMware IT. I have been with VMware for about nine years, and my team is responsible for leading solutions architecture from inception to go live. And today I'm joined by my colleagues Candy and Manas. Candy, would you like to introduce yourself?
Sure, thank you, Swapnil. My name is Candy O'Mara, and I am a Director of Cloud Infrastructure at VMware. I've been with VMware for 10 years, and my team is responsible for the solution design and managing of our cloud infrastructure. Manas, would you like to go ahead and introduce yourself?
Thanks, Candy. My name is Manas, and I'm a Senior Applications Administrator with VMware. I have helped design and implement this Tanzu Kubernetes Grid offering at VMware.
Candy?
Apologies, I was on mute. The agenda for the webinar today, we will provide an overview of our IT landscape. We'll discuss the Tanzu Kubernetes Grid on VMware Stack. We'll cover the key components of our enterprise deployment, including our NSX Advanced Load Balancer. And finally, the Q&A, we will cover as many questions as possible at the end of this webinar. Okay, so let's get started. Okay. So this is our overview of our IT managed environment as of Q2 2020. As you can see, we have a large and complex environment, and we needed a platform solution which can deal with the intricacies involved. In this case, our choice was Tanzu Kubernetes Grid is a platform of choice. What this gives us is the ability to provide efficient container orchestration, easy to scale and manage the services, along with providing security, and provides a faster, more efficient deployment of services to our teams. Okay, so how did we do this? We did this by leveraging cloud native storage, which is bundled with vSphere 6.7U3. Along with, we leverage vSAN as our backend storage. Delay here. NSX-T. Oops. Oh, it's not going good. My apologies, guys. A little technical difficulty here. So NSX-T and our NSX-T NCP, which is our NSX-T NCP API plugin, providing us the ability to provide microservices and microservices within Kubernetes. We also protect and build resiliency within our enterprise Tanzu Kubernetes cluster, and we do this by deploying multiple master nodes. We set anti-affinity rules, ensuring the master nodes are never on the same server, while also we back up our etcd, which is critical to Kubernetes as it manages the configuration data, the state data, and the metadata for Kubernetes. Okay, so let's go into a deeper look into cloud native storage. So cloud native storage is comprised of two parts. Cloud native storage control plane within vCenter, and this manages the life cycle of container volumes. Then there's the container storage interface, CSI, plugin for Kubernetes. This allows a storage class construct in Kubernetes to provide dynamic provisioning for block volumes. Now, how this works is a microservice will request a persistent claim. It will reach out to and talk to the CSI driver, which, whoops, the CSI driver, the request goes to the CSI container interface via the CNS control plane and requests a VMDK to be created. The persistent volume is then presented up and assigned to the microservices. Now let's look at how we can look at this through vCenter view and see the persistent volume within Kubernetes. Here you can see we have the vSAN cluster. And down below you can see under the monitoring, you can see the cloud native storage, which gives you visibility into the container volume. Here you can see the persistent volume itself. It identifies the microservices or pod labeled for it, the data store, and the capacity that's been assigned to that PVC. Now, if you want to go in a little bit deeper, you can look at the details of the PVC. In this case, you can see in the basic view, you can find out which worker node the PVC is attached. And in the Kubernetes objects view, you can see the persistent volume name, along with the microservices in which the application is assigned. Okay, NSX-T for Kubernetes. The NSX-T container plugin, also known as NCP, runs in a Tanzu Kubernetes cluster as a pod and communicates with the NSX manager. NCP provides integration between NSX-T and Kubernetes. So let's say when a pod is deployed, NCP allocates the IP and MAC addresses and connects this to the pod network. This communicates back to the NSX manager about all the new allocations. So when any new rules are created for microsegmentation via NSX manager for namespaces or pods, NCP does enforce the rules. So let's go ahead and take a look at VMware NSX Manager view. It's pretty simple. You can see the views from the pods. In here, you can see the destinations. In our case, we have any. You can also see that the context profile, which allows you to segment out whether you want production to see engineering. In this case, we have it as any, but you can see that the all traffic can either be rejected or blocked or dropped. Let's see what happens with that one. My screen froze. Apologies, guys. So we have the options of allow, dropped, and redirect. So if you are allowing, it allows you to go anywhere within your boundaries. The reject will send a notification back saying that you've been rejected from this access. And a drop will just not inform you of anything and will just drop the access and not allow you any pod routing. Okay, so this covers my portion. Let me go ahead and pass to Manas so he can cover the application overview.
So we'll talk about our current Tanzu Kubernetes grid deployment. We have two clusters in production and 3 clusters in non-production. We have 5 applications which we've deployed to our production cluster. And if we count the total number of microservices, we have more than 1,000 microservices which are in use. 200 of these are in production. And all these applications are business critical applications which we have deployed to Tanzu Kubernetes Grid cluster. So when VMware embarked on the journey of cloud native applications, the first step was converting our monolithic applications to microservices. This was an essential step to achieve agility. We chose Tanzu Kubernetes Grid as the platform for running our microservices. In our current infrastructure, this platform forms the backbone of our cloud native infrastructure. Now, we look at another component of this deployment, that is Tanzu application catalog. We know containers are everywhere today. We directly control the images we use to build our microservice containers. However, when it comes to open source packaged application, there are always questions around origins of the containers and security vulnerabilities. We rely on Tanzu application catalog via kubeapps to provide us secure images of various open source packaged application, which we deploy to this platform. Kubeapps gives us a lot of flexibility in terms of customizing the packaged application deployment. In addition, via kubeapps, the upgrade of the packaged application is literally click of a button. From a platform application administrator's perspective, logs are a key component in root cause analysis cycle. With so many microservices in use, it's difficult to manage individual log files. Here comes in Log Insight. We rely on Log Insight to address our log search and retrieval needs. And the best part, as the platform administrator, I don't have to do housekeeping for the files. We have Fluentd daemon deployed on our Tanzu Kubernetes Grid cluster, which pushes the log from standard out to our Log Insight instance. You can search Log Insight on a lot of criterion like namespace, pods, hostname, or pure text filters. This view shows you some search capabilities where we tried searching using a namespace, and it showed a lot of criteria for exceptions. We rely on vRealize operations for Tanzu Kubernetes Grid on vSAN for monitoring our vSAN infrastructure. It gives us a lot of good metrics about the vSAN infrastructure, which we use to monitor the usage and do debug of the issues we face during our day-to-day operations. Let's talk a little about Tanzu Observability by Wavefront. It is one of the key components in this infrastructure. It provides us lot of visibility into our infrastructure, starting from vSphere up to the Kubernetes and pod level. It's based on a Telegraph agent. We have a proxy deployed on our Tanzu Kubernetes Grid cluster, and we have log collectors deployed on our cluster as well, which helps us propagate the metrics from our Tanzu Kubernetes Grid cluster to our Tanzu Observability instance or Wavefront. So there are a lot of dashboards which come out of the box from Tanzu Observability. In here, I show you one such dashboard, which is the vSphere dashboard. This is an out-of-the-box dashboard, and once you configure your vCenter to push out the data via the Telegraph agent to your Tanzu Observability instance, it shows you a very detailed metrics about your vCenter. I've just shown one summary graph, but there are a lot of detailed graphs about each component of your vCenter infrastructure, like your ESXi host, the VMs deployed, the data store usage, so on and so forth. Similarly, there are out-of-the-box dashboards for Kubernetes as well. The Kubernetes dashboards, they excuse me, work with Tanzu Kubernetes Grid clusters as well in the same way. In the screenshot, you can see it shows the different metrics about our cluster, like number of nodes, namespaces, pods, and so on and so forth. Let's talk about a custom dashboard in regard to Tanzu Observability. So you looked at two dashboards. One was related to vSphere, the other was related to the Kubernetes. However, from a platform administrator's perspective, If you would want to see all the metrics in one dashboard, Tanzu Observability gives you that capability in terms of custom dashboards. I've created a custom dashboard which gives me the metrics related to my vCenter as well as my Tanzu Kubernetes Grid cluster in the same dashboard. You see in the slide, the top portion, I'm displaying the vCenter information. This is the total metrics from my vCenter. I can see the total memory capacity, the used memory, the storage capacity, and the used storage. Whereas in the second portion of the screen, you can see a chart where it shows cumulative memory utilization across my TKG nodes. Bear in mind that when I refer to TKG nodes, these are the worker and the master node, and the memory utilization is only on those VMs and not in the whole infrastructure, or rather the vCenter. So let's look at a little more detailed information about this cumulative memory usage graph. If you click on it, you'll see at the bottom of your screen, it shows the metrics, what is being displayed. Tanzu Observability is very flexible. It gives you a lot of options to tune the data, what you are seeing on a graph very easily. You can see the metrics, what is shown, and you can put it up as a percentage number or as an absolute number. It depends on your preference. Apart from this, you can add additional metrics or create new graphs for different metrics. So in this screenshot, I've shown the various metrics which come out of the box from your Kubernetes cluster. You can see the first parameter is about the memory utilization, where I've shown for CPU, the second metrics related to CPU, like there are various metrics which you can display on your on the same graph. The next critical component which I'll talk about is NSX Advanced Load Balancer, also known as RV. RV forms a key component when we talk about agility. NSX Advanced Load Balancer, or RV, is the ingress component on our Tanzu Kubernetes Grid cluster. It is great for us since we can use annotations to create ingresses on the fly. And this helps with the agility, the faster deployment of services. We do not have to do any complex configurations about creating new webs for services and all of that. We use ingress configuration in our multi-data center setup for applications. So we have an active standby setup, and we have our two different Tanzu Kubernetes Grid clusters deployed in production in two different data centers. We rely on Global Service Load Balancer to provide us with active standby flow of request. So when data center 1 is active, all the requests coming in via GSLB are redirected to data center 1 ingress host, and ingress host redirects it to the respective pod. When we move or fail over to the other side, a similar traffic flow happens on the data center 2 side using RV ingress controller. So I'd like to invite Swapnil to join in and talk a little more about RV here.
Thank you, Manas. Okay, before we begin, I would like to quickly discuss about VMware IT journey to NSX Advanced Load Balancers. Let's start with why we chose NSX Advanced Load Balancer, formerly known as NSX-ALB or RV. So I'll be using these terms interchangeably, so please bear with me. The load balancer landscape has been changing rapidly over the last few years, and the current legacy load balancers that we have in our data center, we were facing several issues with them. And I would like to zero in on few of the key challenges we were facing. So let's first start with the root cause analysis. For most of the applications, generally, the load balancer is an entry point. So whenever there is a problem, the load balancer administrator is the one who gets called. And this is where it has been quite challenging for us to support with our legacy load balancers. The main issue was it simply takes too long to identify the root cause of a problem. The reason behind that is we do not have any historical data, and anytime to do a deep dive into what really the problem is, you generally have to enable the packet capture or enable the additional logging and so on. And that actually in turn puts more load on our load balancer. So that was our first challenge. The next one is the lack of elasticity. Generally, we used to procure our legacy load balancers, keeping in mind about 3 to 5 years of capacity planning. So what that means is we have kind of a fairly rigid model of the load balancer, and which we cannot elastically scale to meet the business changing demands. The next one is VMware IT is in the process of migrating a lot of our workloads to the public cloud. And the public cloud deployment model is significantly different than the on-prem. You need a lot of automation, you need elasticity, and so on. So those features we are lacking as well. And finally, the integration with the cloud native applications. So as Candy and Manas mentioned, we are on a journey to migrate from our monolithic applications to a Tanzu Kubernetes grade. And one of the key component required here is we need to be able to provide full automation so that whenever the namespaces are created, the virtual services IP should be automatically reserved. The virtual service should automatically be created, and it should be automatically registered in DNS. So which unfortunately we couldn't do with our legacy load balancer. And that was quite a bit of a manual effort, and that was affecting our go-to-market. When we looked at the NSX advanced load balancer, we realized that we can solve all these challenges out of the box. So the first thing is we can do the deployment very easily using Ansible automation scripts. So we don't really have to have any manual effort involved there. The next one is the elasticity. NSX Advanced Load Balancer is 100% virtual, and we generally integrate that with our vSphere environment, and it allows us to automatically scale horizontally depending on the workload. So when we deploy this, anytime there is additional requirements, it can automatically scale and create the load balancers on the fly without requiring any manual intervention. Analytics is kind of a centerpiece for NSX ALB, which allows us to perform the deep dive into application traffic. And we'll talk more about it in next few slides. We have automation built in with this load balancer, which allows us to do the integration with Tanzu Kubernetes Grid. And with that, the application team has a full control, and they can just specify the annotations. And then once they do that, they can create their applications. And once the applications are deployed, the load balancer is automatically configured. And in the non-prod environment, when they complete their testing and when they want to dismantle their application with just one single click, and it will automatically delete the virtual services, unregister the IP addresses, remove the DNS records, and they can remove the application automatically. So we removed the manual portion completely from this version. And the final use case is public cloud deployment. About 4 or 5 months back, we had a requirement to deploy Horizon 7 virtual desktop environment in our public cloud. And generally, that deployment would take about 3 to 4 months on average, because you need to procure the hardware, deploy the hardware, configure the Horizon on it, deploy with legacy load balancer, and so on. With combination of VMware Cloud on AWS and NSX Advanced Load Balancer, we were able to complete this task in less than 3 weeks. So before we get into more details, I'm quickly going to walk through the use cases we have for NSX Advanced Load Balancer. Step one is like we wanted to migrate all our remote sites from legacy load balancers to NSX Advanced Load Balancer. So that is almost complete. The next one is a public cloud deployment, like deployment on VMware Cloud on AWS or native AWS deployments. And the data center migration. We have about 4,400 VIPs running on legacy load balancer, and we are in the process of migrating all of those VIPs to the AVI load balancers. But for this presentation, I'm specifically going to focus on Tanzu Kubernetes Grid and how we do the integration with AVI. So let's look at the high level architecture before we go into more details. Unlike the traditional load balancers, you see here the control plane and data plane is separated. By having the separated control planes, it allows us to manage and maintain the load balancer in various locations from one single pane of glass. So let's imagine if you have 10 load balancer pairs in your data center. With the legacy load balancer, we would have to manage, maintain, configure, troubleshoot all of them by logging onto each of them. With this separation of the control plane and data plane, it allows us to manage them from just one control cluster. Regarding elasticity, since we have integration directly with vSphere, we can easily scale the load balancer horizontally. Now let's talk about the supportability. So the NSX Advanced Load Balancer is supported both in on-premises as well as the public cloud. And it provides us a unified load balancer view across the on-prem as well as the public cloud, which becomes quite easy for us to support this. And finally, talking about the intelligence or the kind of deep analysis of the traffic. So let's start with the end-to-end timing, right? Whenever there is an application issue, you generally need to understand where the problem is. By looking at the NSX Advanced Load Balancer controller, you can quickly identify the round-trip response time for the client, server, and application. And you can quickly write the queries to identify the root cause. You can also do a queries based on the SSL version or a specific URL. You can just filter it very quickly. Unlike the legacy load balancer which we had, we didn't have to enable any additional logging or packet capture. This is available out of the box. So for example, if you want to find out how many 404 errors you got, you can quickly just run a historical search and it can generate that report. And you can even set up alerts based on that. You can also see geographically where the traffic is coming from. It also has a built-in security component, which allows you to perform and protect yourself from denial of service attacks. So let's take a look at the logical topology of the load balancers. The first, you have a controller cluster, which is your management plane or control plane. And then next you have service engines. Think about service engines or worker nodes or your actual load balancers. And then there are various load balancer objects such as cloud, VRFs, virtual services, and the pools. And finally, there are tenants. So when an application administrator creates the namespace and provides the annotations, it automatically creates a tenant and deploys the application inside that tenant. So this process is completely automated. Now let's look at the like how exactly we integrate this load balancer with Tanzu Kubernetes Grid. So, and this is kind of a high level step, right? So first you log in to the controller, then you specify the name of your cloud. Then you work with the application administrator and identify the master node URL. And once the master node URL is provided, there is a token which is associated with this URL. You specify that token, and then obviously you would need the licenses, and you provide a tag. It's literally as simple as that. Once you provide that, your cloud will be created, and you'll see as the status, you can see here, it's a green here. So there are various clouds we have, and that's pretty much it when it comes to the integration of NSX Advanced Load Balancer with Tanzu Kubernetes Grid. Now let me quickly show you the high level diagram. Manas touched a bit on this one. I'm going to go a little bit deeper. So as you can see here, we have two data centers, data center 1 and data center 2. So in this example, the top data center is primary and the bottom is standby. Now the primary and standby is determined based on the application response. So our goal here is to provide control to our application teams where they want to route the traffic without any manual intervention. We achieve that by creating a status page which provides a response, and based on that response, the global service load balancer decides where to send the traffic. For example, in this case, the primary site status might just simply say the site is up. And if the site is up, send the request to primary site. And if the site is down, or the status changes on primary side and the status is up on the standby, the traffic is automatically flipped. So this helps perform a non-disruptive maintenance for application team. So if they want to deploy any code, they generally deploy it on standby site first, finish all the testing, then they go ahead and change the status on the primary site. Traffic gets redirected to the standby site, and they repeat the process on the primary site with the code deployment and flipping the switch back and route the traffic back to primary. So this is completely automated in our case. Now I would like to give you the overall architecture, how it looks for our data centers. So here, and this is obviously the logical design. This doesn't really represent our true data center, how our data center looks. But here we have 3 data centers, and each of the controller cluster is deployed in each of the data center. And the controller cluster manages the various Tanzu Kubernetes grid clusters. So here we have deployed 2 service engines uh, per cluster, one Tanzu Kubernetes grid cluster, and they are associated with our prod and non-prod clusters. So this provides a very easy way to deploy and manage and maintain the infrastructure for us. So this is kind of how we are showing you this, so that if you are planning your deployment, we would highly recommend doing it something similar. One thing to remember, and you might be wondering why there are 3 different control clusters and not just one control cluster. There is a latency requirement. When the latency goes more than 55 millisecond, the requirement is that you should have a separate control cluster to ensure your application or your load balancer configuration continues to work as expected. Now let's talk about the analytics piece. And this is where the NSX Advanced Load Balancer is extremely valuable to us. When you log into the controller, the first thing you see is the overall the status of your virtual services. So in this case, we have created the analytics profiles, which allow us to identify if one of the application status is degraded. Now let's talk about how we exactly do that. So we generally work with the application teams and identifying what are the acceptable values for the response time. If the response time is less than 2 milliseconds, we consider, like, for example, the application is working fine. If it goes more than 2 milliseconds, then you start getting the penalty on the health score in this scenario. So in this scenario, for example, your performance health score is 100. That means the application is working as expected, but there is a penalty of 20 for your security. Now this penalty can be multiple things. It could be your cert is expired, or you are running the weak ciphers and so on. So the point here is that by just logging on to this page, you can immediately see which of your applications are working as expected and which of the applications are not working We consider this kind of a brownout situation where the application may be intermittently having problems, or the application may not be working as expected. So you can look at this analytics score over the period of as far as like last 3 months, or you can see just show me for last 2 hours. So it helps a lot when it comes to troubleshooting. Now I'm going to show you how we use the NSX Advanced Load Balancer for additional troubleshooting so that we can triage and identify the issues quickly. So the step one is the latency when the transaction goes through. So we can see the latency from client to server, server to the app server, and so on. So in this case, you can easily see that your latency is around 1 millisecond in most of the transaction, except the app response, which is taking 4 seconds, 4.3 seconds rather. So that means you can easily identify where the problem lies. That's number one. The second thing is you have the real-time insights into where the connections are coming from. So for example, here the connection is coming from the Windows operating system. You can look at what browser it is, what SSL version it is, and so on. You can also filter your traffic based on these patterns as well. And sometimes if you want to trace the transaction, so in this case, there is a persistent ID, session ID, for example, and if the application team want to trace the transaction end to end, you can do that here out of the box. Here you don't have to maintain or deploy any additional logging or packet capture. You can also search for specific URIs, the request from specific IPs, and so on. One more thing I want to show you is when there is a problem, you want to identify the problem very quickly. So to do that, there is a feature called a significance. And in this case, I clicked on the significance and it shows me connection abnormal events. So there are 69 events and their percentage of the logs is like 95%. So you can easily identify if something is wrong just by going to significance. So instead of going through each and every request, running through all the transactions and so on, it allows you to identify the issue very quickly. And we use the significance very often when we are troubleshooting the issues. The next thing I want to show you is the security. The security is very important for pretty much all the organizations, and we wanted to have a single pane of glass view for how the security is for a specific virtual service or specific application. So you can look at the SSL usage breakdown here on the left. So let's start with the first one. So for example, here, if there are any, it tells you the transactions, how many failed transactions are there, what was the SSL TLS version, and it also tells you it might be time to deprecate your old ciphers. The next one is a security score. The security score allows you to identify how secure is your application. The perfect score is 5.0, but in this case, your score you would notice is 3.5. And the reason behind that is it's a SSL protocol strength, and that's why your score was down. So this helps you identify this very quickly. And the next one is, as we discussed earlier, the denial of service attack is provided out of the box here. It helps you identify if your application is under attack. You can create the alerts and you can even block the specific IPs which are causing the problems for you. So this is kind of a high level overview. So we looked at the overall use cases for NSX Advanced Load Balancer. We looked at the overall architecture. We looked at the integration with Tanzu Kubernetes Grid. And finally, we looked at how we perform the analytics. So hope this gives you an idea how using NSX Advanced Load Balancer it's been very useful for us. So we hope that you found this webinar useful. And what we're going to do now is we are going to go to question and answers. So I would request you to post all your questions in the question the question panel, and we'll try to answer as many as we can. So there is a question number 1. Candy, you want to take that one? About the 1,000+ containers. That one.
Sure. So the question is, how many of the 1 million containers weekly created and destroyed are using this TKG deployment? As Manas had mentioned earlier, we have about 1,000 containers currently deployed in our Tanzu Kubernetes grid clusters.
Okay, thank you. Okay, so the next questions is, are VMs also running on the infrastructure along with TKG containers? Candy?
Okay, so yes, we do. Our vSAN clusters can host Tanzu Kubernetes grid. Along with, we can also deploy traditional VM workloads. It allows the flexibility to do both.
Okay, thank you, Candy. Let me take the last question here, which I see. Is NSX deployment on-prem required to use advanced load balancer on-prem? It's not a requirement. NSX advanced load balancer is deployed as a separate product. It is completely okay to deploy NSX advanced load balancer on its own without having NSX in there. So you can definitely do that. Okay. So there is a question, maybe Manas, you can answer this. Beyond 1K, is there plan to use deployment for all of your containers?
Yeah, thanks, Swapnil. So to answer that question, yes, we are in process of migrating more and more applications to our Tanzu Kubernetes grid cluster, and that is a work in progress. And specifically, when we spoke about 1,000+ microservices, those are like the business critical microservices which are currently deployed on this infrastructure.
Okay, thank you, Manas. Okay, so those are the questions we had. We have a little bit time, so while we are waiting, feel free to post your additional questions. Meanwhile, let me quickly go through the VMware and VMware program resources. So we have the blogs, as well as we have the page where if you have any questions, feel free to use these resources. And if you would like to schedule a deep dive briefings directly with your team, we would recommend working with your VMware account executive, and they will be happy to schedule one-on-one briefings with you. Also, there are several webinars which are coming up here soon, and which will be, feel free to register for these webinars from the VMware on VMware site. And you can, once you log into the site, you can register over there. Okay. All right, so let's see if there are any additional questions. Give me 1 second. So Manas, maybe you can answer this. Is Tanzu service mesh being used or planned to be used?
So we are not using Tanzu service mesh currently, but we are definitely progressing towards it. And I see another question about how do VMware developers get into TKG? So the way it works is, as you can understand, this offering is more of a platform offering. So what we do is we create restricted namespaces for our developers and share the respective kubeconfig file with them, and they can directly use it to connect to the Kubernetes cluster and do the deployments or whatever they need to do.
Okay. All right, so let's see if there are any other questions. 1 second. So it doesn't look like there are any other questions. So We'll wait a couple more minutes. If there are no other questions, then we'll conclude the webinar. But we would like to take this opportunity to thank all of you for taking time and joining this webinar. Hope you found this useful, and feel free to reach out to VMware on VMware team if you have if you would like to do additional briefings. Okay, thank you everyone. Thanks for joining.
Thanks, everyone.